All right, so the next set of notes that we were doing are dividing radicals. The reason this is a separate set of notes from the operations with radicals is because there are a couple of processes with dividing radicals that need to be focused on separately. So we're going to start with the beginning of this. So dividing radicals, what you do is you divide the coefficients first, and then you use the quotient rule, which states that if you have a radical divided by a radical, you just divide what is underneath the radical signs together as long as they have the same index, right? So they have to have the same n. And then once you do that, you're going to simplify what's left, if possible. Sometimes it's not always possible to simplify. All right, so we have 12 square root of 160 divided by 2 square root of 5. So we're going to start with dividing our coefficients. So 12 divided by 2 is 6. And then we're going to divide what's underneath the radical sign. So 160 divided by 5 is 32. And now we're going to simplify the square root of 32. So our factors of 32, where one has a square root, are 2 and 16. I know there are others, but 16 is the highest. So it becomes 6 times the square root of 16 times the square root of 2. So then the square root of 16 is 4. So we have 6 times 4 square root of 2. So 6 times 4 is 24. And we're left with 24 square root of 2 as a simplified answer of 12 square root of 60 divided by 12 square root of 5. All right, after the division, this is all stuff we've been doing for months because we've been simplifying square roots since we did imaginary numbers. All right, so for number 2, we have the square root of x cubed y to the 9th over the square root of x squared y to the 5th. So what we're going to do is we're going to deal with the division first and then simplify what's left. So remember, if you have the same base, you subtract the exponents when dividing. So 3 minus 2 is 1. So we have x to the first power. And then 9 minus 5 is 4. So we have y to the fourth power. And now remember, since this is a square root, the index is 2. So we have 1 divided by 2 does not divide into a whole number, so the x is going to stay. And then 4 divided by 2 is 2, so we have y squared square root of x. And that is the answer to our division problem. All right, so our next one, we have 29 cube root of negative 16m to the 9th divided by 4 cube root of 2m. All right, so 29 over 4 does not divide into a whole number, and it does not simplify. So we're going to leave it 29. But we are going to simplify the cube root of negative 16m to the 9th. Actually, no, we're going to subtract first, just because it's going to make this a little bit easier. So negative 16 divided by 2 is negative 8. So you have the cube root of negative 8. And then m to the 9th minus m to the first is m to the 8th. And so we're going to focus on this cube root of negative 8 m to the 8th. So 8 has a cube root. So basically we need to focus on the m. The closest multiple of 8, or the closest multiple of 3 to 8 is 6. So we're going to make this m to the 6th times m squared. And that's still all under the cube root sign. So the cube root of negative 8, which we've already discussed, is negative 2. And then 6 divided by 3 is 2. So we have m squared. And then 2 divided by 3 is not a whole number, so that m squared is going to stay underneath the cube root symbol. Okay. So now this is going to replace this whole cube root here. So we have 29 times negative 2 m squared cube root of m squared over 4. All right. So 29 times negative 2 is negative 58. m squared cube root of m squared over 4. And then we can simplify now negative 58 over 4 because they're both even. So our final answer is negative 29 m squared cube root of m squared over 2. And there we go. All right, so moving on to the next one. So we have 36 fourth root of 1,250 divided by 9 fourth root of 2. So the first thing that we have to do is divide our coefficients. So 36 divided by 9 is 4. And then we have the fourth root, and then we're going to do 1,250 divided by 2. Which is 625. All right, and now we have to talk about 625 in its factors, and if that itself has a fourth root. Let me type that in a calculator here in just a second. So 625. So 625 has a fourth root. I believe it is 5. My calculator's not cooperating, so I have to go to Desmos here. But I do believe it is 5. I believe we're going to get down to 4 times 5, which is 20. Let me just double check. Yep. So the fourth root of 625 is 5. So that just simplifies to this 5. So we're left with 4 times 5, which is 20. All right, so moving on to number 5. So we have the square root of 48 over 16. So just divide 48 by 16, which does divide into a whole number, and we're left with the square root of 3. And there is no further way to simplify that, so it is just the square root of 3 as an answer. All right, so now we have the fourth root of 40 over 27. And this one, 40 divided by 27, doesn't divide into a whole number. And then if you go through and look at the factors of those two numbers, so 40, we have 1 and 40, 2 and 20, 4 and 10, 5 and 8, and then for 27, we have 1 and 27, and 3 and 9. None of these have fourth roots. So this is the final answer for this problem. This is as simplified as it gets. So this is simplified. And there we go. All right, so now that is if you were just given as far as it'll go. Now, our next ones, we're going to talk about what happens when you are left with a radical in the denominator. Because in math, you should not ever leave a radical in the denominator of a fraction. It's just not proper mathematical usage. So the way we do that is called rationalizing the denominator. So it's rationalizing, which is a fun word to spell, the denominator. Denominator is also a fun word to spell. And so what you do to rationalize the denominator is if you have a single monomial in your denominator, so like this 3 squared root of 6, what you would do is multiply both the numerator and the denominator by that radical. So in this case, we'd multiply the square root of 6 over the square root of 6. Okay. So that's what, if you have a single monomial in the denominator. If you have a binomial denominator, so in this case, this 3 plus 2 square root of 7, we multiply the numerator and the denominator by what is called the conjugate, and it's the same expression except with the opposite sign in the middle. So in this case, we would multiply by 3 minus 2 square root of 7, and we would do that on both the numerator and the denominator. So if you get to any point where you have a radical sign in the denominator, you have to do one of these two processes. And we'll talk about how to multiply them when we get to some more examples. This is just how you set them up. All right. So our first example, we have 3 over 2 square root of 5. So because we have the square root of 5 left in the denominator, we're multiplying by the square root of 5 over the square root of 5. So 3 times the square root of 5 is just 3 square root of 5. And now, this is where we have a little bit of a cheat. We have the square root of 5 times the square root of 5. Anytime you multiply two square roots together and they have the same radicand, the answer is just the radicand. So this becomes 2 times 5. Okay. The reason that works is because if you do square root of 5 times the square root of 5, you get the square root of 25, which is just 5. So essentially, we're just skipping this step here and going straight to 5. Now, our last step is just simplify this. So 2 times 5 is 10. So we have 3 square root of 5 over 10. And if you could simplify it further with, like, if this was like a 4 instead of a 3, you could simplify further, but in this case, we're not. And there we go. All right, so for number 8, we're going to rewrite this slightly. Okay, so instead of leaving it as the square root of the whole thing, we're going to make it the square root of 8 over the square root of 15. All right, and now we're going to rationalize the denominator by multiplying by the square root of 15 over the square root of 15. So 8 times 15 is 120. So this becomes the square root of 120 over 15. Now here's the fun part, because we can simplify 120. So the factors of 120 that we are going to use, I believe, are 4 and 30, maybe. Let me just double check here. Yep, so 4 and 30. So we have the square root of 4 times the square root of 30 over 15. And the square root of 4 is plus or minus 2 square root of 30 over 15. And there is our final answer. So just moving on to the next one. We have 3 square root of 12 over 4 square root of 7. So we can't simplify 12 over 7 any further. So we're going to rationalize the denominator here by multiplying by the square root of 7 over the square root of 7. So we have 3. And then 12 times 7 is 84. And then in the denominator, we have 4 times 7. So now the factors of 84, because I'm pretty sure we can simplify that. I believe 4 and 21 are the only ones that are going to work. Yeah. Okay. So we're going to do 2 steps in one here. We have 3 times the square root of 4 times the square root of 21, and then 4 times 7 is 28. All right, so the square root of 4 is 2, so we have 3 times 2 square root of 21 over 28, and then 3 times 2 is 6, so we have 6 square root of 21 over 28. And there is one more step to this one because 6 and 28 are both even, so we can simplify those because we can divide them both by 2, so we're left with 3 square root of 21 over 14. And that is our final answer. All right, so for number 10, we have 28x cubed over 3a. And what we're going to do with this one, because we can't simplify this any further, is the same as we have been, even though there are variables involved. So we're going to multiply by 3, the square root of 3a over the square root of 3a. And we're going to multiply underneath the radical signs. So 28 times 3 is 84. So we have 84. And then x cubed times a, we can't do anything with, so we're going to leave it as a times x cubed. That's still under the radical sign. But now we know it's over 3a. Okay. We can simplify this square root of 84 ax cubed. We just simplified the square root of 84 over here. So we know it's 4 and 21. So we have the square root of 4 times 21 times a. And we can separate the x cubed into x squared times x to the first. So the square root of 4 is 2. The 21 is going to stay. The a is going to stay. And then the exponent 2 divided by 2 is 1. So we have x to the first out here. And the x to the first in there. So we're left with 21 a to the x. And then just bring this 3a over. And this is the answer to that division problem, which seems like it's even more complicated, but that's what it simplifies to. All right, so we have the square root of 8 minus 2 over the square root of 2. So once again, we're rationalizing the denominator by multiplying by the square root of 2 over the square root of 2. Now this one, because there is a binomial in the numerator, we'll have to distribute the square root of 2 in. So the square root of 2 times the square root of 8 is the square root of 16 minus, and then the square root of 2 times the square root of 2 we've talked about is just 2 over 2. Oh, this one's going to be fun because it's going to simplify to a single digit. So now the square root of 16, we know, is plus or minus 4 minus 2 over 2. All right, so technically it's 2 answers. So split it up like we did when we do in quadratic formula. So we have positive 4 minus 2 over 2, and then negative 4 minus 2 over 2. So 4 minus 2 is 2, divided by 2 is 1, and then negative 4 minus 2 is negative 6, divided by 2 is negative 3. So our 2 answers are 1 and negative 3. There we go. All right, so now this is where we have to multiply by the conjugate because we now have a binomial in the denominator. So we have 4 plus the square root of 2. So that means that to rationalize that, we're going to multiply by 4 minus the square root of 2 over 4 minus the square root of 2. All right, so we're going to take a little side journey, and I'm going to show you a shortcut for multiplying the conjugates in the denominator together. So we have 4 plus the square root of 2 times 4 minus the square root of 2. And we're going to do the distributive property twice to show you what's going to happen. So we have 4 times 4, which is 16, And then 4 times negative square root of 2, so minus 4 square root of 2. And then positive square root of 2 times 4, so we have plus 4 square root of 2. And then square root of 2 times negative square root of 2, so we have minus 2. So what's going to happen here is this negative 4 square root of 2 and the positive 4 square root of 2 are going to cancel because there is one positive and one negative. So we're left with just 16 minus 2, which is 14. The shortcut to this is that all we would have had to multiply is the 4 times 4 and get 16, and then square root of 2 times negative square root of 2, which is minus 2. So when you were multiplying conjugates, and this is only when you were multiplying conjugates, you multiply the first two together and the second two together, and that's it. So in this case, for the numerator, we're going to distribute the 4 into here. So 4 times 4 is 16. 4 times negative square root of 2 is minus 4 square root of 2. And then we did the math for this over here. So this is over 14. All right. Now, there is one further step in this because the 16, the 4, and the 14 are all even numbers. So we can divide them by 2, and we get 8 minus 2 square root of 2 over 7. And that is our final answer. And no, you don't divide out the 2 underneath the radical sign because that is its own entity. You just focus on the coefficient and the other two constants. All right, so let's go to the next example. So we have the square root of 3 divided by 1 minus 4 square root of 2. So we have to multiply by the conjugate, which is 1 plus 4 square root of 2. All right, so let's start with the numerator. So we're going to multiply square root of 3 by 1, so we have the square root of 3. And then the square root of 3 times 4 square root of 2. The 4 stays because there's not a coefficient here, and then 3 times 2 is 6, so we have the square root of 6. And now this is where we're going to use that shortcut. So you multiply the first ones together, so 1 times 1 is 1, and then negative 4 square root of 2 times positive 4 square root of 2. So negative 4 times positive 4 is minus 16, and then we have times square root of 2 is 2. Okay, so we have 1 minus 16 times 2. So let's simplify this further. So the numerator, we can't simplify any further. We have the square root of 3 plus 4 square root of 6. But this simplifies to 1 minus 32. And one step further, 1 minus 32 is negative 31. So we have the square root of 3 plus 4 square root of 6 over negative 31. And this is our final answer. And then our last example, we have 5 minus the square root of 5 plus over the square root of 5 plus the square root of 3. So our conjugate this time is the square root of 5 minus the square root of 3. And that is what we're multiplying the numerator and the denominator by. Now, let's do the denominator first in this one because it's going to be a little bit easier. So we have the square root of 5 times the square root of 5, which is 5. And then the square root of 3 times the negative square root of 3, which is minus 3. Now, for the numerator, because these are not conjugates, they're just two binomials that need multiplied together, we're going to have to do distributive property twice. So 5 times the square root of 5 is 5 square root of 5. 5 times negative square root of 3 is negative 5 square root of 3. And then we have negative square root of 5 times the square root of 5, which is negative 5. And then we have negative square root of 5 times negative square root of 3, which is positive square root of 15. All right, now we're going to simplify and rearrange this problem more. So put the constant first in the numerator, so we have -5. And then we can't simplify the square root of 15 anymore. So put the square root of 15 plus 5 square root of 5 minus 5 square root of 3. And then the denominator, 5 minus 3 is 2. There is zero way to simplify this any further. All right, none of these have the same radical and radicand, so we can't simplify or combine like terms. Okay? We can't simplify the square root of 15 anymore. They don't have a common factor. You can't divide any of them by 2 into whole numbers or any of the coefficients. So this is it. This is the final answer. Boom. That's the last example. Have a good day.